Hello, this is Fahad. I'm going to explain to you how we use our multimetering devices to detect electricity and do some diagnostic. The first tool we have is the voltmeter. This pen is basically using electromagnetic field to detect voltage. It's our first tool to know if the circuit is powered or not. If we touch it to the hot line, you see a red light. And if you go through the neutral, you don't see anything. It should be like dead. And if we power up the circuit, see the light is on. We go through the hot line, it's red, and the neutral usually is blue. So you can see the blue line here. So before you touch any circuit, make sure it's not powered by touching the pen to the line and see if it's powered or not. That's our first tool. The second tool we'll use is the multimeter, and I'm using here Fluke 116. If we look at the first setting, it says voltage, and the squiggly line here means AC, which is alternating current, and that's a sinusoidal wave. So I'm going to try to get a measurement for the voltage that's coming into the circuit. So I'm going to touch both lines here. This is the neutral. Just give me actually in the neutral here. So actually I have to go to the plug. Look here. This is our main power source. It should go here, and into the other prong it should be 118 volts AC. If let's say I want to measure the hertz, the frequency, I hit the yellow button here, and this will give me the frequency, which is 59 hertz, which is almost 60. Let's say I want to measure the voltage using the ground. I'm going to do that, but I have GFCI here that will trip. But I will have a trip and reset it. So put it here. Should give you 116. Didn't. The GFC. See, 118. I got it. Yeah. So we get the voltage here. So this is how we measure voltage. So it's back. The second part is for AC voltage, and we can turn to AC. And I have here a transformer connected to the power source. It's transforming 110 volts to 58. So you just put it on the AC voltage and stick it on the exposed area. And it's 48 volts. And you can tell there's a minus sign there. That means I reverse polarity. So if I reverse that, I should be getting 48 volts. All right? This setting here is for very, very small voltage, whether AC and DC. That's for boards and electronics. And this setting here is for measuring resistance. So let's say, for example, I want to measure the resistance across this light bulb here. I'll basically just go cross side, and it's 25 ohms. That's and the second setting is continuity, which basically allows us to measure the continuity of the circuit. And I'm going to unplug this before I start. And I'll start from here. And if you hear the beep, that means the circuit is continuous. If you go from the other switch, it's off. Turn it on, you hear the noise. Go to the next switch. It's on. So we have continuous circuit all the way here. Even if you go to the light bulb, we have continuity. The other setting here is for measuring capacitance. For capacitor, it's in nanofarads. And the last but not least is the temperature here. For the temperature, we need to use special prongs, which is actually a thermocouple that is provided by Fluke, and that should give you the temperature. It's basically a small thermocouple, and if you see here, look here, it's the room temperature now is around 82, probably because I'm touching it. If I keep holding it, it will get hotter and hotter. If I turn on the lights here, touch it to light as it keep heating, you can see going up gradually. So that's actually a helpful tool to have around. The last measurement here is for very small amperage, and in this way we have to connect the circuit in series with the ammeter to be able to measure this kind of voltage. It's very small voltage, a small amperage. And to do that, I'm going to use clip-on meters, alligator clips actually. So I will disconnect the circuit before I do any connection. I'll take one part of the circuit out, clip it on. See in here where it goes to red. Just be careful that you don't touch the wires to each other, because that might cause a spark. And I'll connect back the circuit. Don't turn it on, keep it off. This should give you the amperage. It's giving us around 4.7 or 9 of current being drawn as an AC current here. And yeah, this is how it's done. The last thing I want to show you is using the clip-on meter. Usually we use that for big equipment. I have here a setup for a motor. I'm going to show you how we take the measurement of this motor. I have it connected using alligator clips and a switch. And again, I'm trying not to keep those, I want to keep these wires apart while I'm testing it. And I have the motor loose, so I'm going to have to hold it. So I'll clip this in one of the wires. You can see it's around 2.1 amps neutral. Same thing with the other line. If I clip both of them together, it should give me 0, which is, this is what we get here, also 0 because of the accuracy of the meter itself. Alright, there you have it now. You've seen how to use the voltmeter pin, the multimeter, and the clip-on meter.